In section 10.3, we will look at areas of regular polygons. Parts of regular polygons. Well, if you recall, regular means all sides and angles are congruent. Circumscribe is a circle drawn around a polygon through each vertex. The center is the center of the circumscribed circle. Radius is the distance from the center to a vertex. And the apothem is the perpendicular distance from the center to a side. Make sure you label your circle on the right too with the different parts, the center, the radius, and the apothem. In numbers 1 and 2, we want to find the measures of the numbered angles. In number 1, we have a regular pentagon. So the first thing we need to do is to find the measures of our interior angles. So remember, to find the measure of each interior angle in a regular polygon, we take number of sides, in this case 5, minus 2, times 180, and then we divide by the number of sides, which is 5 here. So each interior angle is 108 degrees. So that means this angle is 108, this angle, this one, that one, and that one. So we're first going to find the measure of angle 3. If the entire angle is 108, then the measure of angle 3 will be half of 108 degrees, or 54 degrees. Oops. Okay, so if angle 3 is 54 degrees, so then we know each of the angles in our triangle are 54 degrees. We have isosceles triangles. That's how we know that they're both 54 degrees. So next we can find the measure of angle 1. So we'll take the sum of the interior angles of a triangle, which is 180, minus 54 minus 54. And we get that the measure of angle 1 equals 72 degrees. And then finally, the measure of angle 2 is half the measure of angle 1. So measure of angle 2, in this case, is half of 72 degrees, or 36 degrees. Just circle our answers. Okay, let's look at number 2. So a similar problem. It says we're given the portion of a regular octagon. So remember, an octagon has 8 sides. So first thing, let's find the measure of each interior angle. So 8 minus 2 times 180, and then divide by 8. So each interior angle is 135 degrees. So that's the entire angle here and here. So all these angles. Okay, so the measure of angle 3 will be half of 135. Or 67.5 degrees. Okay, next let's find the measure of angle 1. So again, that makes each of these angles 67.5. So we'll take 180 minus 67.5 minus 67.5. So that the measure of angle 1 is 45 degrees. And then finally, the measure of angle 2 is half of the measure of angle 1, or half of 45. So angle 2 is 22.5 degrees. Okay, so same idea in problems 3 and 4. In 3, we are given the portion of a regular hexagon. So remember, a hexagon has 6 sides. So let's first find the measure of our interior angles. So 6 minus 2 times 180, and then divide by 6 to find out how many degrees each of our interior angles is. So they're each 120 degrees. So the whole angle is 120. So let's first find the measure of angle 3. We will take half of 120 so that the measure of angle 3 is 60 degrees. So then the measure of angle 1 will be 180 minus 60 minus 60. So measure of angle 1 is also 60 degrees. So we actually have equilateral triangles inside our regular hexagon. And then the measure of angle 2 is just half of angle 1 or half of 60. So angle 2 is 30 degrees. Okay, and number 4. We have a portion of a regular decagon. So decagon has 10 sides. So 10 minus 2 times 180 divided by 10. So the measure of each interior angle is 144 degrees. So that's this angle here, and here, and here, here. Okay, so those are each 144. So the measure of angle 3 will be half of 144. So the measure of angle 3 is 72 degrees. Next, let's find the measure of angle 1. So 180 minus 72 minus 72. So the measure of angle 1 is 36 degrees. And lastly, the measure of angle 2 will be half the measure of angle 1, or in this case half of 36. So the measure of angle 2 is 18 degrees. Okay. Next, we are going to look at the area of a regular polygon. And the area of a regular polygon is half the product of the apothem and the perimeter. So we're going to use the formula that A equals 1/2 A times P. P being perimeter, A being apothem. And make sure you label your figure. Remember, the apothem is the perpendicular line segment from the center of the circle to one of the sides of our polygon. And then perimeter is just all the sides added up. In number 5, it says find the area of the regular decagon. Okay, so we're given two things. We are given that each side is 8 inches and the apothem is 12.3 inches. So remember our formula, A equals 1/2 apothem times perimeter. Let's first find our perimeter. So perimeter is just number of sides times each side. So we have a decagon which has 10 sides. Each side is 8 inches. So our perimeter is 80 inches. And then to find the area, we will take 1/2 times, times 12.3 inches times 8 inches. Okay, and then just multiply straight across, we get that our area is 492 inches squared. Okay, In number 6, it says find the area of a regular polygon with 20 12-inch sides and a 37.9-inch apothem. Alright, so remember, area equals 1/2 apothem times perimeter. And let's first find our perimeter. So we have 20 12-inch sides, so 20 times 12 inches. So our perimeter is 240 inches. They give us the apothem, so we'll just substitute that in. Area equals 1/2 times 37.9 inches times 240 inches. So our area here is 4,548 inches squared. In number 7, we want to find the area of the regular hexagon. We are given that each side is 10 millimeters, but we are not given the apothem. If you notice, we have a special right triangle here, a 30, 60, 90, with our short side being 5 millimeters. So our longer side, which in this case is the apothem, would be 5 square root 3 millimeters. Okay, then we're able to find our area. Remember, area equals 1/2 apothem times perimeter. To find the perimeter, we'll take number of sides, so it's a hexagon, times each side is 10 millimeters. So the perimeter is 60 millimeters. Then to find area, take 1/2 times 5 square root 3 millimeters times 60 millimeters. Okay, if we multiply straight across, we get 150 square root 3 millimeters. And if we want to round that to the nearest whole number, that's about 260 millimeters squared. Number 8 says a library is a regular octagon. Each side is 18 feet. The radius of the octagon is 23.5 feet. Find the area of the library to the nearest foot. So let's first draw an octagon. So we have an 8-sided figure. Okay, with the center of the circle. It said each side is 18 feet. The radius is 23.5. So that's from the center of the circle to a vertex. And that's 23.5. Okay, let's continue our triangle by drawing in the apothem. So there's our right angle. This is the side that we want to find. Now, the apothem also cuts the base in half, so this side now is 9. So if we know 2 of our 3 sides in a right triangle, we can use the Pythagorean theorem to find our third side. So I want to solve for a. So a squared plus 9 squared equals 23.5 squared. So a squared plus 81 equals 552.25. So subtract 81, a squared equals 471.25. And then taking the square root, a is about 21.71 feet. Alright, so now we know our apothem. Remember, area equals 1/2 apothem times perimeter. So let's find our perimeter. octagon has 8 sides. Each side is 18 feet. So our perimeter is 144 feet. All right, now we have all the information to find our area. So area will be 1/2 times 21.71 feet times 144 feet. So our area to the nearest foot is 1,563 feet squared. In number 9, we want to find the area of the equilateral triangle, and we are told that the apothem is 4 meters. Well, remember, an equilateral triangle, the measure of all your interior angles is 60 degrees. So if I draw in my radius, center the circle to one of the vertex, then I have a right angle, then this angle in the corner is 30 degrees. It's half of 60. So that makes the top angle 60 degrees, which means my apothem is my short side in a 30, 60, 90 degree triangle. So if that is 4 meters, the longer side will be 4 square root 3 meters. So will this side. So it makes the whole length of the equilateral triangle sides 8 square root 3. Okay, so now we know sides are 8 square root 3, apothem is 4. So remember, area will be 1/2 apothem times perimeter. For perimeter, we need to take 3 times 8 square root 3. So perimeter is 24 square root 3 meters. Then to find area, we'll take 1/2 times 4 meters times 24 square root 3 meters. So our area is equal to 48 square root 3 meters squared. And we'll leave that one in radical form, but you could use your calculator to round if you needed to. In number 10, we're going to find the area of the regular hexagon. Okay, so remember, in a hexagon, we want to find first the measure of each interior angle. So we'll take 6 minus 2 times 180 divided by 6. So each angle is 120 degrees. So that's the entire angle down here. I am given a radius of 2 inches. I'm going to draw in my apothem, which is the perpendicular line segment from the center to one of the sides. So now this angle is 60 degrees, so then my small angle up top is 30. 2 is the radius, which is the hypotenuse in our right triangle, so then that means my short side's 1. My long side is square root 3, which will be the apothem. So area equals 1/2 times apothem times perimeter. The whole length of a side of the hexagon is 2. So first, the perimeter will be 6 times 2 inches. So my perimeter is 12 inches. Then my area will be 1/2 times square root 3 inches times 12 inches. So our area is equal to 6 square root 3 inches squared. And we'll leave this answer in radical form as well.